So thank you guys for joining me today. First problem, we are given a truss. C is hinge. A is a roller. And we are looking to figure out the internal forces in member AB, AD, CD, BC using the joint method. Regardless what are the members required, first step, I have to start with reactions. This is the first step. Go ahead and put your reactions. Since at A we have a roller, so we will have only one reaction YA. Since C is a hinge, so we will have two reactions. One is called XC, and the other one will be called YC. To figure out your reactions, we have three equilibrium equations. Summation of all forces in X equals 0. Summation of all forces in Y equals 0. Summation moment at any point equals 0. So no excuse at this moment that you still struggling in calculating reactions. No way. First of all, you need to figure out what are the types of supported you have. Then you need to put your reaction. Then you need to apply your equilibrium equations. Three equilibrium equations for reactions. So I will start with summation of all forces in X equals 0. I think I have positive 600. I think I have XC negative based on my assumption equals 0. The only unknown in this equation is your XC. XC will be 600. So this reaction will be 600. Summation of all forces in Y. We have positive YA. We have positive YC. We have negative 400 equals 0. So I can rearrange this equation. YA plus YC will equal 400. I cannot do anything more because I have two unknowns. Summation moment at any point equals 0. I'm going to take moment at C. I do recommend to take moment at the point with the highest number of reactions, C. I'm going to assume my counterclockwise rotation is my positive direction. So I have to list everything. XC will be multiplied by distance. YC will be multiplied by distance. 600 Newton will be multiplied by distance. 400 Newton will be multiplied by distance. YA will be multiplied by distance equals 0. So I listed everything. I listed everything in the problem. So what is the distance between XC and point C? The distance is 0. What is the distance between YC and point C? The distance is 0. What is the distance between 600 Newton and point C? The distance will be vertical distance, which is 4 meters. What is the distance between 400 and point C? The distance will be horizontal, 3 meters. What is the distance between YA and point C? The distance will be horizontal, 6 meters. I don't care about the direction or the sign of this term or the sign of this term because they will be 0. 600 times 4 will rotate counterclockwise. It will be positive. 400 times 3 will rotate counterclockwise. It will be positive. YA is rotating clockwise. It will be negative. The only unknown in this equation is YA, so I can figure out the value of YA. It will be 600 times 4 plus 400 times 3 divided by 6. Your reaction will be 600. Will be 600. If you go back here and put YA equals 600, based on this equation, I think YC will be negative 200. It's very important. Be careful, be careful, be careful. Because reaction YA equal positive 600. So this one is 600 in the same direction. YC equal negative 200. This direction is wrong. This reaction should be coming down. So the correct direction should be down. This is the correct one. How much? 200. Keep in your mind the negative value for the reaction YC. That means you assumed the wrong direction. I did assume it to upward. I'm sorry, it should be downward. So this is the first step. You have to figure out your reactions. Any question so far? Guys, do you have any question, any comment about the reactions? Second step. I'm looking for the internal forces in member AB. This one. And the member AD. This one. Let's focus on the first two members. The first two members are intersecting at A. This is my first joint I need to start with. So I will start with joint A. Here is joint A. We have to consider everything intersecting at A. So I will have reaction YA equals 600. I will have this horizontal member with a force called FAD. I will have this member intersecting at A with a force equal FAB. Nothing else. Nothing else is intersecting at A. I have only reaction YA. I have only this member. I have only this member. That's it. Keep in your mind this angle theta equal to this angle theta. By the way, this angle theta inside a right angle triangle. This right angle triangle has 3 meters in this side, has 4 meters in this side, has 5 meters will be in this side. And this is your angle theta. So the value of sine and cosine can be figured out. Let's go back. So for joint A, I will apply summation of all forces in X equals 0. I will apply summation of all forces in Y equals 0 for joint A. Does that make sense? If you apply summation of all forces in X, we have positive FAD. We have positive FAB cosine theta equals 0. We have this force and we have the X component for this force, FAB cosine. Keep in your mind that cosine theta equals 3/5. So this term equals 3/5. Summation F of I equals 0. We have positive 600. We have positive FAB sine theta equals 0. Keep in your mind that sine theta equal 4/5. The only unknown in this equation will be FAB, so I can figure it out. It will be negative. Negative 600 divided by 4/5. It will be 750. If you go back here and put FAB negative 750, the value of FAD will be positive 450. We have one comment here. FAD equal positive value. That means I assumed the direction for FAD correct. This direction related to joint A is tension. It's correct. tension. So if you go back, FAD is tension. This one will be tension. And this one will be tension from the other side. How much for FAD? It's 450. One more comment. FAB equal negative. That means the direction you assumed for FAB is wrong. I assumed it tension. I'm sorry, it's wrong. It should be compression, not coming out. It should be coming in the joint. So the correct direction here will be coming in compression to the joint, and it will be coming in the other joint to be compression also. How much? 750. Does that make sense? These are the first two members. These are the first two members. We still have two more. We are looking for member CD, this one, and the member BC, this one. So which joint I'm gonna start with? The joint of the intersection between the two members. CD and BC are intersecting at C, so I will work on joint C. Here is joint C. What do you have at joint C? What we have here at this joint? I think I have horizontal reaction 600, like this. I think I have vertical reaction YC coming down. This is the correct direction, equal 200. So I will have vertical reaction coming down 200. This is the correct direction for reaction YC. And this is the correct direction for reaction XC. What else? I have this horizontal member. So I will have a force FCB. And also I have this vertical member with a force equal CD. Does that make sense? These are all what do you have at C. One more time, at point C, we have this member, we have this member, we have this reaction coming down, we have this reaction coming to the left. Anything else intersecting at C? No. This is your joint C. Go ahead and apply summation of all forces in X equals 0. Summation of all forces in Y equals 0. You can find out what you are looking for. Summation f of x equals 0, I have negative 600. I have negative FCB, that's it, equals 0. So the value of FCB will be negative 600. That's fine. Summation f of y equals 0, we have negative 200 coming down. We have negative FCD coming down also, equals 0. So the value of FCD will be negative 200. What is the meaning of negative value? You assumed the wrong direction. You assumed the wrong direction. I assumed the FCB coming out from the joint. This direction is wrong. It's not tension. It should be compression. So FCB should coming in the member, in the other side of the same member with a value equal 600. FCD equal negative. FCD, I assume the FCD coming out from the joint. I assume the tension. Unfortunately, it's wrong. It should be compression. So the force in this member will coming in the joint and will coming in the other joint with a value 200. So by the end, I found up the reactions. I found the forces in members AB, AD, CD, and BC. and I indicated if the member is tension or the member is compression. Does that make sense? Do you have any question regarding this problem? Any answer? Guys, do you have any question? We are missing someone. Okay. Guys, do you have any question? Can you say yes or no?
No.
Okay, thank you. Just to make sure you are still here. Second problem. The second type of problem, I'm giving you a truss, and I'm not asking to calculate reaction. I'm not asking to figure out the internal forces in some members, but I need you to identify all zero force members. I would like to remind you that zero force member can be figured out using two cases, if you remember. Case number one, or the first one, if you have a joint with two members only, no external force or reaction are given at this joint, the two members will be zero. We have another case. If you have a joint with two members, I'm sorry, with three members, but two of them are collinear. Two of the three members are collinear. No given external force or reaction at this joint, the third member will be zero. Before starting, I do recommend to redraw your truss. So I will redraw my truss using my pencil. Like this. This is my truss. We are given support at A roller. This one is roller. And the support at E as a hinge. So keep in your mind, we will have one reaction at A and the two reaction at E. And we are given a force here 700, and we are given another force here 500. As I mentioned, I don't care about the reactions. I don't care about any calculation. I need only to identify, do you have this case or this case to say this member will be zero? I think let's start with this one. Do you have a joint with two members only? Yes, we have this joint A with two members only, but we have a reaction at A, so forget it. At joint E, this joint has two members only, but unfortunately we have reactions at this joint, so forget it. Looks like this case does not exist. We don't have a joint with two members only and no given reactions or force at this joint. We have a joint with two members, but we have reactions. That makes sense? So I will forget this case. Let's try to find out this case. Do you have a joint with three members? Two of them are collinear, no external force at this joint? I think yes. We have this joint. We have this joint. Thank you. Joint B. Make sure the conditions are satisfied. At this joint, we have three members. Two of them are collinear. No given force, no reaction. The third member will be zero. So I can circle this member. I'm not asking you to clarify or to explain why this member is 0. This is for you, yourself. But keep in your mind, if your member is 0 fourth member, I can delete it. I can delete this member. Once you deleted this member, I would like to recheck, do another check. Do you have a joint with 3 members? 2 of them are collinear and no a given external force? I think yes. Right now, after I deleted the 0 force member BG, I think joint G has 3 members. 2 of them are collinear, no given force, no reaction. The third member will be 0. So this member also will be 0. Looks good. Go ahead and delete this member because the member is 0. So at this time, I can say also joint C. Right now, joint C has 3 members. 2 of them are collinear. No given force, no given reaction. So the third member will be 0. So this member also will be 0. I can delete it. Once you deleted this member, looks like I will have another joint here, joint F. Joint F. I'm sorry, wait a moment. I have technical issue. Just a moment. Yes. Joint F. Hey, everybody, can you hear me? Okay, thank you. So joint F at this moment has 3 members. 2 of them are collinear. This one and this one are collinear. No external force, no reaction. The third member will be 0. So this member will be 0. Keep going. I will delete this member. One more check before finishing up the problem. One more check. Do you have joint with 3 members? Looks like we don't have any joint with 3 members anymore. Do you have joint with 2 members and no given forces or no given reaction? No way. We are done. That's it. You don't need to write anything. You don't need to explain anything. Just circle the 0 force members. I have 4 members: BG, CG, CF, DF. That's it. Any question about this problem? So my recommendation, don't forget to redraw your truss. Don't forget to redraw your truss with your pencil so you can erase the 0 force member. So redraw your truss with a pencil, then you can remove the 0 force member. I have another example here. I'm looking to figure out the internal forces in members KG. This one, KJ, I'm sorry, KJ, not KG, KJ, KD, and CD using a section method that we covered last meeting. Regardless what is the required, I will forget everything right now and I will focus only on the reactions. We must start with reactions, even if the problem did not ask you, because the reactions will be used in your calculation. So A is a hinge. I will have 2 reactions, YA, XA. G is a roller, so I will have only 1 reaction, YG. If you would like to figure out these reactions, I need to apply the 3 chromium equations, summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. This is how to figure out your reactions. What do you have in x? Do you have anything in x direction? Make sure you include everything. I think I have only xa equals 0. That's fine. 0 is good. Summation f of y equals 0. We have positive ya. We have positive yg. We have negative 20. We have negative 30. We have negative 40. Do you think we have any more? In y direction, looks like no. Ya, yg positive, negative 20, negative 30, negative 40 equals 0. So I can say ya plus yg will equal 90. Looks good. Summation moment. I do recommend it to take moment at A, the point with the highest number of reactions. It's up to you, but for me, I'm gonna assume any clockwise rotation will be positive. Let's start. I have to list everything. XA time, YA time. We have 20 kilonewton time. We have 30 kilonewton time. We have 40 kilonewton time. And we have YG time equal 0. I listed everything. I did not forget any. Keep in your mind that the distance between XA and the A is 0. Between YA and the A, 0. Between 20 kilonewton and the A, 2 meter. Between 30 kilonewton and the A, 4 meter. Between 40 kilonewton and the A, 6 meter. Between YG and the A, the whole distance, which is 1, 2, 3, 4, 5, 6, 12 meter. That makes sense? This term, I don't care about this term. I don't care about this term. 20 will rotate clockwise. The rotation for 20 kilonewton about A is clockwise. 30 is the same. 40 the same. YG is going up. It will rotate counterclockwise. It will be negative. The only unknown in this equation is YG. I can figure out the reaction YG. It will be 20 times 2 plus 30 times 4 plus 40 times 6 divided by 12. I got 33.33. Let me check it one more time to make sure I got it correct. Yes. If you go back here and put YG equal 33.33, I think the value of reaction YA will be 67. 56, I'm sorry, 56.67. 56.67. That make sense, yes. So this reaction YA is correct direction, 56.67. This YG correct direction because you have a positive value, 33.33. This is the first step, how to figure out your reactions. Second step, which is very important, and I need everybody to pay more attention. I'm looking for member KJ, member KD, and member CD using a section method. So the next step, I need to cut this truss. I told you before how to cut your truss. You have to pass through the required members. Your section is passing through the required members. So I will do cut like this. Your section passing through KJ, KD, CD. Once you cut your truss, this section divided your truss to two main parts. This is the first part, or this is the second part. Which part I'm gonna use? The green one on the left or the blue one on the right? It's up to you. You can use any. Both of them works. Both of them works. So I will use the left part. I do recommend to use the smallest part. So I will use the left part. What do you have on your left? I have these members. Let's do it here. I have these members. A, B, C, K, L. A, B, C, K, L. These members, I did not touch them. I did not touch this member, this member, this member, this member, this member, this. I did not touch these members. So I will keep them as they are. I have two reactions at A. One reaction here equal 56.67. I have horizontal reaction here equal 0. I am given two vertical forces at B and C, 20 and 30. Nothing else. Nothing else, but keep in your mind. We did cut in this member. So I will have a force like this. How much? F, K, J. I did cut in this member. So I will have a force K, D. I did cut in this member. So I will have a force F, C, D. Does that make sense? That makes sense? So guys, how to use the section method? We need first to start with reactions. Once you did your reaction, I will cut my truss. And keep in your mind, your section will passing through the required members, the three required members. So I did this cut. This cut divided your truss to two parts, one on the right, one on the left. It's up to you. This part or this part. You can use this one or this one. I decided to use the left side. So I draw the free body diagram for the left side. We have reactions, we have forces, we have members. I did not touch. The member you did cut, I will put forces in these members, like them. Once you set up your part, I can apply summation of all forces in X equals 0 for this part. Summation of all forces in Y equals 0 for this part. Summation moment at any point equals 0 for this part. Does that make sense? Let's start to apply summation F of X. What forces do you have in X? We have 0. We have positive F Kj. We have positive F CD. And we have positive FKD. FKD. I think this angle theta, how much? Do you know? This angle theta. I can set up this triangle, right angle triangle. This horizontal length equal 2 meters. This vertical length equal 3 meters. So how much is this one? Okay. So it will be 9 plus 4 square root of 13. So sine angle theta equal 3 divided square root of 13. Cosine angle theta equal 2 divide square root of 13. That makes sense? I set up a right angle triangle for the angle theta, so I can work on this. So keep in your mind, for summation F of X, FKG, KJ, FCD, and FKD, cosine theta equals 0. keep in your mind the value for cosine theta based on this right angle triangle to divide square root of 13. I cannot do anything more for this equation. Summation f of y, we have positive 56.67. We have negative 20. We have negative 30. We have negative fkd sine theta equals 0. For y direction, we have this one, we have this one, we have this one, and we have the y component of this one. Keep in your mind, sine theta equals 3 divide square root of 13. The only unknown in this equation is fkd. I can figure it out. So fkd will be 56.67 minus 20 minus 30. Your value will be positive. Divided by 3 divided square root of 13. Your value will be 8. Positive. Summation moment at any point equals 0. I'm gonna take moment at point K, this point. Taking a moment at this point will help you to cancel this one and cancel this one. So if you take moment at point K, this is K. And I'm gonna assume, it's up to you. Counterclockwise is my positive direction. So I have to list 56.67 time distance, 20 time distance, 30 time distance, FCD time distance, FKJ time distance, FKD time distance equals 0. I listed everything. I did not list this 0 because it's a 0. So let's start. What is the horizontal distance between 56.67 and the point K? What is the horizontal distance? I think we have 2 meters and 2 meters. It will be 4. Between 20 and the point K, the horizontal distance will be 2 meters. What is the distance between 30 and the K? It will be 0. Hey, the horizontal distance. Why are you asking for horizontal? Because your 30 is a vertical force, so your distance must be horizontal. What is the horizontal distance between point C and the point K? We don't have horizontal distance, 0. What is the vertical distance between FCD and the K? Why vertical distance? Because your force is horizontal. So the vertical distance equal 3. What is the distance between FKJ and the K? 0. What is the distance between FKD and the K? 0. I think this direction will be clockwise. I think this direction will be counterclockwise. This direction, I don't care. This direction will be counterclockwise. Positive. I don't care about this one. I don't care about this one. Just imagine FCD will rotate around or about K counterclockwise, which is positive. This 20 counterclockwise, which is positive. Why 56.67 will be clockwise, will be negative. The only unknown in this equation is FCD. I can figure it out. FCD will be negative 56.67 times 4 plus 40 divided by 3. This value will be positive 62.2. If you go back here and put the value for FCD 62.2 and the value for FKD 8, I can find out the value of KJ. It will be, I think, negative 66.67. Keep in your mind, the value of FKJ is negative. That means you assumed the wrong direction for FKJ. This direction is wrong, which is coming out from the joint. This is wrong. You assumed a tension. I'm sorry. It should be compression. Coming in, not out. FKD is positive. You assumed the correct direction. I assumed the FKD coming out from the joint, which is tension. It's correct. The force FCD is positive. That means you assumed the correct direction. I assumed it coming out from the joint, which is positive tension. It's correct. Tension. So by the end of my solution, I can figure out the three forces in the three members, and I can identify if the member is under compression or under tension. Does that make sense? This is how to solve your truss using a section method. I have to start first with reactions. Then I will do my cut. I will decide to use, for example, the left part. So I will draw the left part. I will put the forces in the member that I did cut. I will apply three equilibrium equations. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. I can find out the forces in the required member. If this force equal positive, you assume there's a correct direction. If these forces are negative, you assumed the wrong direction. Do you have any questions so far? Guys, do you have any question? Okay, the last problem that I would like to cover today, this one. We are given a truss and we are looking to figure out the internal forces in two members AI and AB using section method. Using joint method. And we are looking for the forces in members ED, EH, GH using section method. So regardless what is the requirement in this truss, I have to start first with reactions. Since A is hinge, I will have two reactions, YA and XA. Be smart. I assume the XA this way because I'm feeling that 40 and the 30 trying to push this truss to left. So your reaction will be to right, whatever. And we have one reaction at F, Y, F. Once you put your reactions, I will apply three equilibrium equations. Summation of all forces in X equals 0. Summation of all forces in Y equals 0. Summation of moment at any point equals 0. What forces do you have in X? We have positive XA. We have negative 30. We have negative 40. Do you think we have more? No. Equals 0. So the value of XA will be positive 70. Positive means I assumed the correct direction for XA, 70. Summation of all forces in Y equals 0. We have positive YF. We have positive YA. We have negative 40. We have negative 50. That's it. Equals 0. So I can simplify this equation. YF plus YA will equal 90. Summation moment at any point. I do recommend to take moment at A, the point with the highest number of reactions. I will assume my counterclockwise is my positive direction. Go ahead and list everything. YA time distance. XA time distance. 40 time distance. 30 time distance. 50 time distance, another 40 time distance, YF time distance equals 0. I listed everything. Keep in your mind, I'm sitting at A. I am here. What is the distance between XA and A, YA and A? 0, 0. What is the vertical distance between 40 and A? Your distance will be vertical, 1.5. Between 30 and A, the vertical distance will be 3 meters. What is the distance, the horizontal distance between this 50 and A? Horizontal distance. Don't forget, because your force is vertical. We don't have horizontal distance. What is the horizontal distance between this 40 and the point A? The horizontal distance will be 2 meters. What is the horizontal distance between YF and the point A? The horizontal distance will be 4 meters. I don't care about this term. I don't care about this term. I don't care about this term. This 40 will rotate counterclockwise, positive. This 30 counterclockwise, positive. This 40 counterclockwise will be positive. YF is clockwise, will be negative. The only unknown in this equation is YF. I can find it out. This reaction will be 40 times 1.5 plus 30 times 3 plus 40 times 2 divided by 4. I got positive 57.5. Positive means I assumed that the correct direction for this reaction 57.5. If you go back here and put YF 57.5, I can find out the reaction YA. It will be positive 32.5. Positive means I assumed that the correct direction for YA 32.5. Does that make sense? This is the first step, which is reactions. This is the first step. Second step, we are looking for member AI. Where is AI? This one. And the member AB, this one. Using joint method. So what do you think? Which joint I'm gonna start with? The two members intersecting at A. So I will work on joint A. Joint A. Here is joint A. Let's see what do you have at joint A. First, at joint A, we have horizontal reaction 70. This way. We have vertical reaction at A, how much? 32.5. At joint A, we have this vertical member AI. And we have this inclined member AB. Nothing else. If you go back here, everything intersecting at A, we have vertical reaction, horizontal reaction, this member and this member. That's it. That's it. And I'm gonna assume this is my angle theta. And keep in your mind, this angle theta will be inside right angle triangle. This is angle theta. Can you go back? This triangle exactly like this triangle. So this is your angle theta. Based on the given dimension, the vertical dimension 1.5, the horizontal direction is 2. So this one is 2, this one is 1.5. So I can say the third member will be 4 plus 1.5 square. It will be 2.5. Yes. So I can say sine theta will be 2 divided 2.5. Cosine theta will be 1.5 divided by 2.5. That makes sense? Let's go back. Once you set up your joint, I can apply summation of all forces in X equals 0 for this joint, summation of all forces in Y equals 0 for this joint. In X, we have positive 70. We have positive FAB sine theta. Do you agree? Equals 0. Keep in your mind, the value of sine theta equal 2 divided 2.5. The only unknown is FAB. It will be a negative value. How much? 70 divided by 2 divided 2.5. I got 87.5. Looks good. Summation f of y equals 0. What do you have in y? We have positive 32.5. We have positive FAI. We have positive FAB cosine theta equals 0, the vertical component of this force. Keep in your mind, the value of cosine theta equal 1.5 divided by 2.5. The value of FAB is negative 87.5. The only unknown right now is FAI. I can find out this force. It will be positive 20. What you mean by negative and what you mean by positive? Negative value here means you assume the wrong direction for FAB. I assume the FAB coming out from the joint, which is tension. Unfortunately, it should be compression. FAI positive, that means you assume there's a correct direction for FAI. I assume the tension, it's correct. So I figured out the internal forces in the first two members. And I identified these members are tension or compression. We have another part. We are looking for members ED, EH, and GH using a section method. So I will need to do cut. Your cut will pass through the required member. Does that make sense? So I did another cut. I combined the two methods in one problem. So the first method, joint method, to figure out the internal forces in these members. The second method, section method, to figure out the internal forces in these members. So it's okay. I started with the action. I finished up the joint method. Now I'm working on the section method. Keep in your mind that this section divided your truss to two parts. This part, and we have another part. It's up to you. It's up to you. You can use the right part or you can use the left part. For me, I'm gonna use the left part, which is the smallest part, to be more easy. So let's focus on the left part. So I will start here saying for section method. I did not touch the three members. So I will have the three members without touch. I am given vertical reaction here at F 57.5. I am given a force at this joint 40 kilonewton. That's it. Nothing else. I did not touch these forces or reaction or these members. Keep in your mind, I did cut in this member, so I will have a force FED. I did cut in this member, so I will have a force FEH. I did cut in this member, so I will have a force FGH. Nothing else. Nothing else for the left part. That makes sense? Do you think I'm wrong? In the left side, we have this reaction, these members without touch. And I did cut in this one, did cut in this one, did cut in this one. That's it. So I can apply the three equilibrium equations because we have a part. Summation of all forces in X equals 0. Summation of all forces in Y equals 0. And the summation of moment at any point equals 0. Keep in your mind this angle equal to this one. I can label it alpha. This angle inside this right angle triangle, alpha. The horizontal distance will be 2 meters. The vertical one, 1.5 meters. And the third one will be 2.5. So sine alpha equal 1.5 divided by 2.5. Cosine alpha will be 2 divided 2.5. Go ahead. I will start with cosine summation f of x. What do you have in x? Positive FGH. We have positive FED. We have positive FEH cosine alpha equals 0. Summation f of y. We have positive 57.5. We have negative 40. We have negative FEH sine alpha equals 0. I think from this equation I can find something because sine alpha equal 1.5 divided by 2.5. I can find out FEH. It will be 57.5 minus 40. It will be positive. Divided by 1.5 divided by 2.5. I got 29.17. The third equation, summation moment at any point. I do recommend to take moment at this point for many reasons. E. I will take moment at E, this joint. I'm gonna assume my clockwise rotation is my positive. If you take moment at E, 40 time distance is 0. FED will be time 0. FEH will be time 0. All of these three forces at joint E. So the distance for these forces will be 0. And FGH will be multiplied by the vertical distance, which is 1.5. And 57.5 will be multiplied by the horizontal distance, which is 2 meters. Equals 0. This term will be cancelled. This one will be cancelled. FGH rotating counterclockwise, 57.5 rotating clockwise, it will be positive. The only unknown here is GH, I'm sorry. I can find it out. It will be positive 76.67. If you go back here and put the value for FGH, 76.67, FEH, 29.17, cosine alpha 2 divide 2.5. The only unknown is FED. I can find out the value of FED. It will be negative 100. What you mean by positive value? It's tension. I assumed is a correct direction. Negative value, I assumed is a wrong direction. It should be compression. Positive, I assumed is a correct direction, which is tension. So by the end, I found the three internal forces in the three member, GH, ED, and EH using the section method.